Hey guys, this is going to be a video that goes over the molarity and dilutions practice that we had you do. So the big thing I was kind of getting from some of y'all's emails is you are forgetting how to find just molarity, so that's what this equation is here. So you should have just finished up the dilutions guided practice using this equation. So all of these problems down here are a mix between these two things. So the first two, you guys can see you have to find and use the molarity equation from above. So the first thing I always like to do is make sure that you're doing the algebra and isolating your variable. So on number 1, it's asking about how many grams. So that means you are going to have to first find the moles using this equation. So when you rework it algebraically, this is what you're going to get. On problem number 2, it's the same thing, right? But this one says how many moles specifically. So I just let you guys know, right? We already did that equation. We figured out what it is. And we're going to use the same one on number 2. Number 3, 4, and 5, I'll use the dilution equation from up top. So every time I approach these problems, I always list out my variables, so known and unknown. And from there, I can then go to this side, right? And here's all my algebra, so you guys can see how I got my equations. All right, so for the first one, using our equation that we figured out previously, I'm just going to go ahead and set up my numbers and do my calculation from there. So once I do this successfully, I can see that I have 1.5 moles of my potassium sulfide, okay, but the question is asking you for grams. So in order to convert our moles to grams, you need to find the molar mass for your potassium sulfide. So it comes out to be 110 grams per mole. So now from there, we're going to use this to convert. All right, so going from there, we're going to use our molar mass here. So I just rearranged so I had more room. So grams is going to go to the top because that's what we're trying to get into, and moles falls to the bottom so that this cancels accordingly, and you should get 165 grams. Okay, keep in mind that based on this number, you're going to need 3 sig figs and scientific notation, so go ahead and take that decimal, move it twice, and just so happens that that also gives us 3 sig figs. So for number 2, before you start, notice that your volume is in milliliters, so you're going to need to set up that conversion, right, and get that into liters. So you should get 0.45 liters there. Okay, and now you can just take this number and apply it using that equation. So we're going to times it by our molarity given here to calculate the moles, which comes out to be 0.1125. Okay, and then keep in mind you're going to need 3 sig figs based on this number. So 1.13 times 10 to the negative 1 mole is going to be your final answer on number 2. Okay, so moving on to problems 3, 4, and 5. Remember, these are all dilutions, so I went ahead and set up all of my known and unknown variables, and then I'm just going to use the equation that I previously determined from earlier. All right, so I went ahead and set everything up. So for question 3, question 4, and question 5 down here at the bottom. So once you do that, just to give myself a little more space, so now you just have to plug your numbers in. So for the first one, this is what you should have gotten, okay, and according to this number and this number, you're going to need 2 sig figs. Okay, so 2.6, we didn't have to move the decimal, so it's just times 10 to the 0, and make sure you put your unit there. On number 4, right, just do your math, but one thing to make note of if you didn't notice, you're given milliliters, so you're going to have to convert to liters, which is how I got this number. So once you do that math, you should have gotten 0.01667, so on and so forth, liters. Okay, according to this number and this number, you're going to need 2 sig figs. So you'll also need to move the decimal back twice. So 1.7 times 10 to the negative 2 liters. Okay, on number 5, same thing. If you notice, you're given milliliters, so you're going to have to convert that into liters, which is how I got here. So now just do the math and you should get 1.95 liters. So this number that you got is actually the total volume of the new solution that you're trying to make. So the only reason I point this out is because I want you to go back to the problem, and it says how much water should be added in order to create this new solution with the 2.5 molarity. So knowing this, we're going to have to do one extra step. So as I said, right, the volume we found is the total, which means that it includes the volume of the water and the volume of the stock solution that we used, which was actually given to us in our problem. So using that volume that I solved for, the 1.95 liters, I'm just going to plug that into this simple subtraction to figure out, right, how much water I need. So remember, this number came from the problem before, right, the 750 milliliters, but you have to convert into liters before you try and use it. So once you do this, you should get 1.2 liters, and this is of water. And this is our final answer. You do not have to put it into scientific notation because we're just doing simple subtraction. Alright guys, so if you have any more questions, just let me know. I hope everyone's doing okay, and I guess I'll see you once we're back on campus.